Overview on Unit 8 here. Unit 8 was the one where we solved some polynomial and rational inequalities. So here's a couple practice problems. There's more on resources available. Let's just try a couple. So basically you got to get one side equal to 0. So x squared minus 9x minus 36 is less than or equal to 0. And then we factored. So basically we're coming up with what values we can put on this number line. All right, factors of 36, so 12 and 3 are going to work here. So minus 12 and plus 3. So that gives me x values of negative 3 and x value of 12. So one way to go about this, it's not the only way, but one way to go about it is to put in that negative 3 here and that 12 here and realizing there's 3 regions. Well, which of these regions is going to create true solutions? That's essentially what you're asking. Well, a little bit different than true solutions when you have a 0 here is you can say positive and negative regions. If I put a 13, 14, 15, 10,000, anything over here, if I put that into this first factor, any of those numbers plus 3 is going to give me a positive number, okay? Then I'm going to multiply that by, like 13 minus 12 will be another positive number. So this is a positive region in here. If I take 0 that's in here and plug it in, I'd get a positive and I'd get a negative. So I get a positive times a negative. That's really a negative region. And a very large negative would add 3 and become a negative times a very large negative minus 12 is a negative. We'd have a negative times a negative, which is a positive region. Well, that's just to tell me what the numbers would be because I'm comparing to 0. Well, any negative numbers would give me a true solution, a true answer if I thought about this, if I considered this, because less than or equal to 0 would be negative numbers, where greater than would be positive numbers. So we want to actually, let me take the blue here, and we want to shade, since it says less than or equal, we want to shade the negative region. Not the negative numbers on the number line, but the numbers on the number line that give me negative numbers, because they will be true statements. And then I need to use brackets for this one because the problem has a bracket in it. All right, so looking here now, kind of the same, some of the same concept here, except for we don't need to do much solving here. We just need to say, hey, x could be negative 4, x could be 1. Those are the two zeros for the top. But on the bottom, we need to consider that x cannot be negative 9. All right, those are all of our boundary points, or where this is going to cross the x-axis, or where we're going to have situations where it changes from positive to negative y values. So what I got to do is just put this on the number line. So I got negative 9, I got 1, and I got myself 4. It's definitely not to scale. So when I run through my calculations, start way over here again, a very large positive will be a positive times a positive over a positive. So this is definitely a positive region. The number 2 is in here. 2 plus 4 would give me a positive times 2 minus 1 would be a positive over 2 plus 9 would be a positive number. Oh, because I realized I just screwed something up. And this is good because I'm human. I'm going to back up. I went too fast. Watch me. Undo, 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 undo. Stay with me. Well, now I'm redoing. Sorry. Undo, 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 undo. All the way back to, where should I undo back to? All the way to me going too fast here. The x value is actually negative 4. So I'm sorry about that. It's not 4, it's negative 4. The x value is 1. And then the x value that we cannot have is negative 9. All right, that was fun. Now we're back. So now I got negative 9 here. Then I got negative 4. And then I got 1. All right, so now if I try to do positive and negative regions, the same test I did a minute ago will be true. This will be a positive region. But now if I plug in 0 in here, 0 plus 4 is positive, so that's a positive, times 0 minus 1 is a negative, over 0 plus 9 is a positive. I will actually get a negative region right there. Okay? And then I can plug in anything in here. So negative 5. Negative 5 plus 4 will give me a negative times negative all over a positive. Well, the negative times negative is a positive over, that's a positive region. And then if you test a point over here, you'll end up getting a negative. It doesn't always go every other, but that will work out for this one. Because I'll have a negative times a negative, which is a positive, and I'll divide by a negative to give me a negative. All right, well, in this problem, here it is. we want to shade greater than or equal to 0. So we want to shade the positive regions, this one here and this one here. But we need to realize, oh, we want to use brackets, but we can't use a bracket on -9. So I actually have to use a parenthesis there, shade, 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 bracket there, and then what would this, sorry, come back, okay? Then this would be a bracket on this one, shade, 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 forever, ever, and ever, okay? I just realized on the last problem, man, I've really screwed up this one that I did not do interval notation. So there's interval notation, just so we're all clear on that one. And then interval notation for this one would be -9 to -4 bracket, union bracket 1 to infinity.